All right, now that we went over the state and the plan, let's take a look at what the actual tests look like. All right, remember with your plan portion, I apologize, we went over the state and the conditions. So for this, let's take a look at how we define the null and alternative. Once again, remember your null and alternative are always in terms of the population proportion, and there's no numbers here. We don't know the population proportion of population 1 and 2, so we have to just use, are they equal or are they less than? So P1 is the proportion of teenagers from 1998 to 1994 with hearing loss, and P2 is the proportion of teenagers from 2005 to 2006 with the hearing loss. So just be careful with that. Make sure that you are actually taking a look and defining those, because that's important, because every hypothesis test uses P1 and P2 when we're dealing with two sample proportions, and how do we know what is different for each section? So let's make sure that we include that. All right, now let's do our do portion. So we're going to state our statistics. We have our sample proportion 1, sample size, sample proportion 2, sample size, and our critical z-score. Now remember what the critical z-score does is that tells us what is the statistic that I'm going to get. If it's a number different than that, okay, is it below it or above it, which puts us in the rejection versus the non-rejection region. Here's our pooled value. Now notice our pooled value is us just taking the 351 students plus the 450 teenagers divided by the total sample size. So I'm just literally combining my results to get a pooled proportion of 0.167 that you're now going to use for your standard error, and you should have used it for your previous part in your normal condition. Now, what probability are we checking? We're checking the probability that P1 is less than P2. Now, make sure whenever you are doing this, when you're checking these probabilities, this is always going to be in terms of your sample, okay? So this needs to have a P hat on it. Why is that? Because when we actually do the calculations, we are checking to see if the sample proportion of 1 is smaller than the sample proportion of 2. Okay, here's our here's our Z test statistic. So the Z that we find is actually going to be our test statistic. Okay, and make sure you label this Z. Don't just write equals, make sure you label Z equals. Notice here, this is our difference in our proportions. This comes from P1 minus P2. Now, how do you know what to do first? So if you're not sure, and this is what your alternative looks like, kind of just make put 0 on the other side. So if I were to subtract, I would do P hat 1 minus P hat 2 becomes less than 0. So then that tells me what to subtract first. So make sure you do that. Where's the 0 come from? Remember that comes from our null, where P1 minus P2 is equal to 0. The difference in the proportions is none. And notice down here we have our standard error based on the pooled value. Now, I highly suggest that you use your graphing calculator to get the answer, and on your free response, all you're literally going to show here is the numbers plugged in. So we found our test statistic T to be negative 4.05. Okay, now we're finding the probability that Z is less than negative 0.405. And why did we do less than? Well, we did less than because in my alternative, it's also less than. The other thing I wanted to show you here is if you're not sure how to get this on your graphing calculator, just make sure here this is your normal CDF. Okay, since we want less than, it's negative 1,000. Common negative 0.405, okay? And then also on your curve, here's your critical z-score. Your critical z-score is 1.645, okay? And what is our test statistic T? Well, it was negative 4.05, so that's pretty low, okay? So that's going to be in our rejection region. So what conclusion can we make? We can make that conclude that there is sufficient evidence to show that the proportion of teenagers with the hearing loss has increased from 1998 to 2006. So notice this is in support of the alternative. Now, This should say if the true proportions were the same. So notice we're not giving a number here because what was the null? The null was that P1 is equal to P2. If the true proportions were the same, the probability of getting a difference, okay, because what did we test? We tested the difference. We were subtracting them. As extreme as ours is 0.00026. And remember, that's the interpretation of your p-value. Since the p-value is less than alpha, it's statistically significant at the 0.05 level, and we reject the null. Now, if I'm asking for 4 steps, okay, or 4 parts to your answer, remember part 1 is you're always going to include reject or fail to reject the null. Okay, and then you're going to tell me, is it statistically significant or not? Then you have your interpretation of your p-value. And then notice how that first sentence says there's sufficient evidence to show that the proportion of teenagers has increased. That's just giving a sentence about what you're supporting here. Okay, so between the 2 studies, Apple introduced the iPod. If the results of the test are statistically significant, can we blame iPods for the increased hearing loss in teenagers? Let's think about that for a second. No, why not? Here's the reason. We didn't do an experiment where we randomly assigned some teens to listen to iPods and others to avoid listening to iPods. So we can't conclude that iPods are the same. It's possible that teens who listen to iPods also like to listen to music in their cars, and perhaps the car stereos are actually causing the hearing loss. So just be careful with that. We'd have to do a test in order to determine that. Now, let's say you want to use your calculator. Definitely do that. Just make sure you show your numbers correctly plugged into your formula. In this case, you're going to go to Stat, Tests. Here you're going to scroll down to 2 proportion z-test. Remember, your x1 is your number of successes. If they did not give you the number of successes here, then you need to make sure that you plug in your p-hat value times your total sample size, and it has to be whole numbers. It cannot use decimals, okay? And then here's your number of successes for your second sample size, your total sample size. In this case, we're checking to see if P1 is less than P2, okay? Notice how this is a P1 right here. That's why it's important to understand and define your P1 versus your P2. Hit calculate and notice it gives you everything. Gives you your z-score, your test statistic, gives you your p-value. E to the -5 means, remember, I'm moving my decimal 5 to the left. Okay, so there's your p-value. And then notice how it gives you your 2 p-hats value. And what is this right here? This is your pooled value. Okay, so your calculator also gives you that, so you can always check it to make sure you're doing it correctly. So I kind of use my calculator to do it and then plug my numbers into my formula. All right, so inference for experiments. So many important statistical results come from randomized comparative experiments. Defining the parameters in the experiments is a little bit more challenging. So most experiments on people use recruited volunteers as subjects, and that makes it a little bit tricky because the subjects aren't always randomly selected. Therefore, when we have an experiment, we can't always generalize the information to the larger population. Okay, so be careful about that. Researchers can draw cause and effect to people who took part in the experiment, but unless the experiment units were randomly assigned and randomly selected, we can't necessarily establish cause and effect to the larger population. So unless the experimental units are randomly selected, you don't need to check the 10% condition. Okay, if they are just volunteers, you don't have to check that condition. So just be aware of that and read carefully. All right, so take a minute and read over the summary, and congratulations with finishing inference for proportions, 2 proportions.